Good day, guys. You are welcome back to ID International Academy online class. I want to believe that you are enjoying every moment in the channel. God bless you. Today, we want to open the ground by providing the solution to the previous assignment, which I believe every one of us has tried your hand on it. Question 1 in the assignment. Solve x squared plus 4x minus 21 equals 0 by factorization method. Multiply the first and last term together, you have minus 21x squared. Because minus 21 times x squared gives minus 21x squared. Underline it. Then go ahead to underline the middle term, plus 4x. The coefficient of x squared, the absolute coefficient of x squared, that is, when I say the absolute, without considering the negative sign. So, bring it out. Find the possible factors of 21. 3 goes in 21 7 times. Can 3 and 7 give us 4? Yes, it's possible. How? 7 minus 3 equals 4. That means 7x and minus 3x are the two factors we are using there, which, if they add together, gives 4x. Let's try whether their product will satisfy also the product of first and last term. 7x times minus 3x, that gives minus 21x squared. Exactly. Once these two factors satisfy the two conditions, then we regard them as viable factors. They are viable factors. So we use x squared. In place of 4x, we put plus 7x minus 3x. Then we introduce minus 21 equals 0. X into x plus 7 here. What is common here? Minus 3 into, use the minus 3 to divide minus 3x, you have x. Minus 3 to divide minus 21, that's plus 7 equals 0. The inside of the two brackets must be the same if we are correct, and you can see they are the same. So x plus 7 into x minus 3. We factorized x plus 7 out. The x and minus 3 that are left behind, bring them together, equals 0. Don't forget, x plus 7 is equal to 0, or x minus 3 is equal to 0. X equals minus 7 or x equals 3. Therefore, x is equal to minus 7 or 3. So minus 7 and 3 are the roots of this quadratic equation, using any method to solve it. But here, we have used factorization method. Question 2 in the assignment. I want to believe you get the first one. And let's move on. Question 2. Solve 2x squared plus x minus 1 equals 0. The same process. 2x squared times minus 1, that is minus 2x squared. Underlined. The middle term is also another target. Positive 2, that is the absolute coefficient of your x squared here, is what we have to bring out for analysis. What are the factors of 2? 2 into 1. So 2 and 1 are the factors of 2. How do we manipulate 2 and 1 to get positive 1 as the coefficient of this middle term? Or else, 2x and x. That is 2x and 1x. But we will write 1x as x. How do we use 2x and 1x to achieve positive x? We have 2x minus x, meaning that this second factor will be minus. Do you understand? So 2x and minus x are the two factors in algebraic term, in algebraic sense here. So their resolution will give us x, which is the middle term. what of their product? 2x times minus x, that's minus 2xk. It gives us also. So far the two conditions are satisfied at the same time, so the two factors are viable to be used. So we, in place of plus x, we use plus 2x minus x. After all, plus 2x minus x is x. Minus 1 equals 0. What is common to these two? 2x. 2x into x plus 1. 2x into x, 1. Minus. What is common there? 1. Minus 1 is common. Bring it out. Use minus 1 to divide minus x, you get positive x. Use minus 1 to divide minus 1, you get positive 1. Answer is 0. X plus 1 into 2x minus 1 equals 0. Don't forget, x plus 1 will be equal to 0, or 2x minus 1 is equal to 0. So x equals minus 1, or 2x equals 1, x equals half. That is it. Let's go to question 3. How many of you got it exactly like this? Question 3. If minus 2 over 3 is a root of 3x squared minus 4x equals 4, find the other root. Simply go ahead to solve the equation given. 3x squared minus 4x, bring them together on one side, minus 4 equals 0. I hope you understand what I've done there. You bring this positive 4 to this side to become negative 4, and 0 is left there. So, multiply the first and last term to get minus 12xk. Underline the middle term is a prime target there. So the coefficient of the product here, the absolute coefficient is 12. It is from the 12 you will find the possible factors that will serve the purpose we want here. 2 here, 6. Can 2 and 6, 2 and 6 are factors of 12. Not all the factors, but at least they are part of the factors of 12. So can 2 and 6 give us minus 4? Yes. How? It cannot be 6 minus 2, because 6 minus 2 will be 4, and that will not work. It will be 2 minus 6, which is going to be minus 4. So you will use 2x and minus 6x, which if we operate them together, 2x minus 6x will give us minus 4x. The target is reached, middle term. Let's try the product. 2x times minus 6x equals minus 12x squared. Another target is reached. Once the two targets are reached, then the factors used are viable factors. So you now use the two factors to represent the middle term as 3x squared. Instead of writing minus 4x, we write minus 6x plus 2x minus 4 equals 0. 3x is common here. We have 3x into x minus 2. You use 3x to divide this, you get x. You use this 3x to divide minus 6x, it gives minus 2. Plus, what is common here? 2. Bring it out. 2 divide, you use the 2 to divide positive 2x, it gives you x. You use the positive 2 to divide negative 4, it gives you negative 2 equals 0. So, x minus 2 is common to the two terms. You bring it out. Left there will be 3x plus 2, which is equal to 0. So x minus 2 will be equal to 0, or 3x plus 2 equals 0. So x equals 2 or 3x equals minus 2, while x equals minus 2 over 3. Mind you, the question has given us clearly minus 2 over 3 from the beginning, that it is a root of the quadratic equation, and we have to find the other root. So here, out of the two roots here, which one is the one demanded? The positive 2, because minus 2 over 3 has been given to us from the beginning. You write, therefore, the other root is 2. That's the end of that. The last question in the assignment, question 4. If half is a root of 2x squared minus 15x equals minus 7, find the other root. Just like we did question 3. Solve 2x squared minus 15x plus 7 equals 0. You bring minus 7 from that side to this side. So this multiply this, that is 14x squared. Underline the middle term. It is the 14 there we analyze. 2 in 14 is 7. How do we use 2 and 7 to achieve 15? It's not possible by addition, not possible by subtraction. So 7 in 7, 1. So integrate this to give you, harmonize this to give you 14. So you have 14 and 1. How do we manipulate 14 and 1 to get minus 15? That is simple. Minus 14 and minus 1. So bring the variable in touch, minus 14x and minus x. Adding them together, you have minus 14x minus x, and that gives you minus 15x. Can you see? We achieved the middle term target. Let's see if the two factors we achieve at the same time, the product target, minus 14x times minus x, which is minus times minus is plus 14x times x, that is 14x squared. Correct. They also achieve that. So that means the two factors there are viable enough to be used to represent the middle term. So we use 2x squared. In place of the middle term, we write minus 14x minus x, then plus 7 equals 0. 2x is common here. Bring it out. You have x left, minus 7. Minus. What is common here between x and 7? It seems nothing is common. Whenever it seems nothing is common, 1 will be common. Put 1 there. Minus 1 outside here now. Use it to divide minus x. It gives you positive x. Use minus 1 to divide positive 7. It gives you negative 7. Check the inside of the two brackets. You can see they harmonize. They are in harmony. There is harmony. So, bring x minus 7 out. Here, you have 2x left. Bring it out here, you have minus 1 left. Equals 0. So x minus 7 is equal to 0, or 2x minus 1 is equal to 0. X equals 7, or 2x equals 1, x equals half. Don't forget, it has been given right from the beginning that half is a root of the equation, which is true. We have found it. So find the other root. The other root will be 7. You see, therefore, the other root is 7. That is the end of the solution to the assignment. You can now move on to today's work, the business of the day. I want to believe we have settled that of assignments. Fine. Solving quadratic equation by completing the square method is the business of the day. You want to see how to solve any quadratic equation that comes your way using completing the square method. There are 3 steps in all. 3 steps. How many steps? 3 steps. And once you don't miss any of them, you are good. And out of these 3 steps, one of them may naturally not be present. So you just deal with only 2 steps. You will see when we come across something like that. Step 1, separate the constant. Separate the constant. Once you master the 3 steps, the method is simple, it's not confusing, it's straightforward. But master the steps and take the action there. Separate the constant. What is the constant in this quadratic equation? That minus 3 is a constant. A constant is a non-algebraic term, a pure figure. So, separate it. It will now be 2x squared plus x equals positive 3. Separation. Take it to the other side. Negative 3 becomes positive 3. And once it is the only one there, you don't need to put the positive there. If you put it there, it's not a crime, but it's not necessary. Anybody that sees it like this knows it is positive, naturally. So that's a step. It's gone. The second step is divide each term by the coefficient of x squared. If it is p, that is our variable, of p squared. If it is y, that is our variable, of y squared. If it is m, that is our variable, by m squared. Of m squared. So, but today it is x. The coefficient of x squared is 2. Use that 2 to divide each term. 2 divides 2x squared, it gives you x squared. 2 divides x, it gives you x over 2. 2 divides 3, it gives you 3 over 2. The second step also gone. You know, I don't write that one down. I only formalize it. And the step is divide each term by the coefficient of x squared. Or you want me to write it down? Not necessary. Good. So, this is second step. Now, the final step before we now begin to do simple arithmetic procedure. That final step is hard. I will write that one for you because it's averagely long. But it has to be living inside your oblongata. Don't forget, it must be living where? Inside your brain. Good. Hard. The square of half of the coefficient of x at the current level, here, at the current level above, to both sides. It's not ambiguous. Let me simplify it. Don't say, this is too long. It's not too long. After all, where do I write my own? From the head. So you are better than me, if you don't know. Students are always better than their teachers. Because you have no wife now, no children, it's just your book, face it. So in hard the square of half of the coefficient of x at the current level above, to both sides. What do we mean? You know, at the beginning, the coefficient of x at the beginning is 1. Look at it. I point to it. The coefficient of x at the beginning is 1. But at this current level here, the coefficient of x is half. It's half. How? Let me show you. Coefficient of something is something that has multiplicative relationship or attachment with the thing. Let's rewrite x over 2. X over 2 could be written as half times x, isn't it? So 1 over 2 is what is having multiplicative attachment with x, and that 1 over 2 is the coefficient of x. Though written this way, you must know it is still the same thing as this. So in this case, we are interested in the coefficient of x. We are interested in finding the half of that coefficient of x. We are interested in squaring that half. So what is the coefficient of x at this level? Half. What is half of it? Times half. To half something, what is half of 20? Half of 20 is 10. How do you get it? Half times 20. It gives you 10. This is it. Half times 20. 2 here, 1. 2 in this, 10. So it gives you 10. The same thing. When you want to get half of anything, just write half times that thing. It will give you. So we are particular about the coefficient of x at this level. The coefficient of x is this half. Now, we want to find half of that half times half. Whatever it is, which is 1 times 1, 1. 2 times 2, 4. So 1 over 4 is half of the coefficient of x. What else are we particular about there? Squaring that half. 1 over 4 is half of the coefficient of x. And we are to square that half. That half of the coefficient of x, which is 1 over 4, we are to square it. So you have 1 over 4 in bracket raised to power 2. That jargon that you are looking at is what we are to add to both sides. So you now write x squared on this side plus x over 2. You know, we are done with what is on this side. Equal sign demarcates these two sides of the equation. So we now want to add to this side 1 over 4 raised to power 2. Do you understand? Now, to the other side as well, what is on the other side? 3 over 2 is on the other side there. We are adding also to it 1 over 4 raised to power 2. That is to say we are fulfilling the mandate of adding the square of half of the coefficient of x at the current level to both sides, which we have done now. So in them, bring these and these together, you will see they have power 2. They have power 2 in common. So you bring them together, x. Whatever sign of the 1 over 4, if it is minus, you put the minus in place. If it is plus, as it is, invisible plus there, you put that invisible plus now visibly here. Plus 1 over 4. Bracket it. The common power 2, bring it there. Which is equal to 3 over 2 plus, now evaluate 1 over 4 raised to power 2. How do you evaluate it? 1 square is 1. 4 square is 16. So you have x plus 1 over 4, which is equal to square root of plus or minus square root x plus 1 over 4, which is equal to plus or minus square root of, you find the LCM of this. Finding the LCM of this, you have 16. LCM of 2 and 16 is 16. 2 in 16, that's 8. 8 times 3 gives 24. Plus 16 in 16, 1. 1 times 1, 1. I continue on that side. So you have x plus 1 over 4 equals plus or minus square root of 25 over 16. 24 plus 1. 24 plus 1 is 25 over 16. So we have x plus 1 over 4 is equal to plus or minus, square root of 25 is 5, square root of 16 is 4. So, collecting the like terms, we have x is equal to minus 1 over 4 plus or minus 5 over 4. This positive 1 over 4 On getting to the other side of the equation, it becomes negative 1 over 4. And it is meeting there, plus or minus 5 over 4. Now, here comes the important step in completing the square method. You see this double sign, plus or minus. You have to write the expression, and write the equation with either plus or minus at a different time. Minus 1 over 4. In this plus or minus, you take plus at a time, plus 5 over 4. Or you take the space will contain it, or minus 1 over 4 minus 5 over 4 equal to, LCM here is 4 minus 1 plus 5, or LCM here is 4 minus 1 minus 5, which is x equals 4 over 4, or minus 6 over 4, and finally x is 1 or minus 3 over 2. That is it. That is the solution of this quadratic equation using completing the square method. I want to believe you understand. Thank you.